Hello and welcome to NextGen Industrialist podcast. Our guest today is Will Drewery, the founder and CEO of Diagon, a best-of-breed e-procurement SaaS platform, equipping the manufacturers and factories of the future. Will leverages a background overseeing complex technical products for iconic brands such as Tesla, Astra, and Bright Machines. He's also ex-PwC and ex-Google. I first met Will 16 years ago after the collapse of Lehman Brothers and during the Great Economic Recession of 2008. We've since stayed in touch over the years, mostly on LinkedIn, as we all do, including the time when he was at Harvard Business School. Since that time, it seems to me, Will, you finally found your calling as a problem solver, an advanced manufacturing leader, a procurement tech entrepreneur, and of course, now a next generation industrialist. I am super excited to get into this conversation with you, for the community to get to know you and hear you talk about Diagon and your vision for the future of factories. Before we begin, I want to thank you for spending time with me. This is actually a real experiment for me to invite people I admire into conversation. And when I do these things, I always liken my interviews to storytelling. And so I'm going to start with that question. But before you answer, I want you to know that you are absolutely control. You can answer the question or not answer the question any way that you want to. So what is your story, Will? Can you share that with the audience, please?
Happy to share my story. First of all, I want to thank you for having me on your show. It's been a pleasure just getting to know you and to grow career-wise with alongside you over the years. And so, having this conversation is really, I think just amazing that what you're doing in pulling together, the next generation of industrialists. And the fact that I get to be one of them is a treat for me. So thank you for having me.
You're welcome.
So, my story. I'm happy to give you, maybe a quick an overview of my story and in my own words, and I'll try to keep it relatively brief, so that way, if there are different things that you want to dive into, we can talk about those. So, I'm going to start by taking you way back to my upbringing. I was born and raised in Pittsburgh, Pennsylvania. So, if you're not familiar with Pittsburgh, Pittsburgh is an old steel town. It's really had its heyday in the early 1900s, being the steel factory, not just for the country, but really for the world. And Pittsburgh made steel products that were exported, to different parts of the country for everything from everyday appliances and tools that people use, all the way up to really large infrastructure projects like bridges and other kind of civil works projects. Fun fact: Pittsburgh has more bridges than any city in the U.S.
Hmm.
And almost in the world. We've got I think it's like over 1,000 bridges crossing over
Wow.
our three major rivers. And so the reason why I start the story there is that this was really my upbringing was in a very blue collar town where we Pittsburgh is well known for making hardware products. Pittsburgh went through lots of boom and bust cycles, and I'm happy to say that Pittsburgh is kind of now back in a boom cycle. But around the time I was coming up, the steel industry was globalizing. There was a really heavy push to outsource production for steel and steel products to other
Hmm.
countries like India, South Korea, and other places. When the major economic trends in the U.S. were pointing toward deindustrialization, and to put it lightly, the trends were really pointing toward, less blue collar jobs, less manufacturing, and more service oriented jobs. That was really a kind of a sad time for Pittsburgh in its life cycle. There was rampant unemployment, lots of people out of work, all of the problems that come along with that, declining budgets, homelessness. unemployment, all of those things were really the context of the city that I was growing up in. And so to say the least, manufacturing was not a career track that was encouraged when I was growing up. My dad was one of 20 kids. He was, I don't know if I ever told you this, but my dad was one of 20. He was number 15 out of 20.
Wow.
And my grandfather and I'm pretty sure all the men in the family, all seven, my dad and six of my uncles, all worked in the steel mills. And they were really big advocates of me going off to get an education so that I never had to do any kind of
Mm.
work in that domain. And so, to their surprise, a few decades later, when that's what I chose as my career track, they were not initially weren't as receptive to it. But I'll get to that part of the arc of the story. So, I talked about Pittsburgh. That was one of my earliest formative experiences and memories of manufacturing in the context that it comes from, and the kind of pain that Pittsburgh and most of the cities in the Rust Belt, cities like Cleveland, Detroit, St. Louis, Cincinnati, have all kind of gone through a similar bust cycle. And after I kind of graduated, I went off to undergraduate, get my undergrad degree at Carnegie Mellon. I spent 4 years there trying to decide what I wanted to do next in my career. I decided to take on a track in consulting. I worked out of the Washington D.C. area for PricewaterhouseCoopers, PwC, and spent the next 4 years working with different government agencies, helping them with accounting and internal controls work. I spent 2 years working for NASA, a year working for the Department of Justice under the FBI, and then I spent the remainder of my time in the Department of Defense working on a project for them where I was deployed to live and work in Baghdad for a year on, of all things, an industrial manufacturing redevelopment program. And so that was in 2008, 2009. And I spent that entire year working with 15 factories that were selected by the Iraqi government, the Iraqi Ministry of Industry, and helping those companies get equipment that they needed to reindustrialize. Basically, there were these factories that were distributed all over the country, and in most of the areas where they had I would call it like the lowest level of security, these were areas where there were once thriving factories and manufacturing hubs, but most of the people were out of work because there wasn't functioning equipment or infrastructure for these companies to be productive. And it was eerily reminiscent of my upbringing in Pittsburgh when I got to see some of the problems that were plaguing these industries. And during our time there, our mandate was essentially to help these companies get equipment. We were sourcing things like um, cement tumbling machines and electricity generators for companies that were building cement factories that served the construction industry because cement is the number one building material there. We
Hmm.
were sourcing things like tire presses to serve the trucking industry. Trucking was the number one way of getting goods in and out of the country from countries like Saudi Arabia and Turkey. And then things like sewing machines for companies that made uniforms for first responders. So police officers, firefighters, they need uniforms. And so these companies were making uniforms for those service providers, and we were helping them source equipment that they needed to get back on their feet. And so it was really just one of the most fascinating experiences that I've had. I really fell in love with not only the work, but also the impact that manufacturing is able to make on countries and regions that are investing in those types of things. And that's really what's one of the things that set the course for the rest of my career that
Wow.
going to work in manufacturing. So I'm going to take a pause here just to debrief if there's anything that you want to double click on. There are just so many lessons and things to unpack from there.
Yeah, I think it's fascinating to, again, I'm from Nigeria, West Africa. I've been in this country quite some time. And as a US citizen, I'm always amazed when I learn about these stories about, Pittsburgh and Detroit and the evolution and devolution of these cities that were really the bedrock of American industry. And, hearing you talk about your experience as a consultant working in Iraq and actually helping them reindustrialize, what was that moment like for you? I mean, maybe what was the lesson lost on you? Or were you like, what was your feeling around that? I'm just curious.
Yeah, the lesson was not lost on me. I will say, if there's one experience that really stands out to me that really like crystallizes that one of the lessons I learned there. We were working with this factory. I mentioned the cement factory, and it was the state company for cement products in Fallujah, Iraq.
Okay.
And I remember meeting with the director generals. These director generals are because these are state-owned factories, they're essentially the CEOs of the factories. And we would meet with them and then do a factory tour. We would work with the engineering teams that are sourcing the equipment and make sure that they get what they needed. And so in the meeting we had with this director, he was telling us about the security situation in Fallujah. It was pretty notorious notorious for being one of the places that had the worst fighting in the country during the war. And the director was telling us about how this factory was one of the tallest structures in the city, and that the military groups or paramilitary groups would stake out inside this factory, and camp out in the highest parts of the factory and shoot down at American forces and other people that were driving by on the highway. And I remembered asking him, like, "Oh my God, that's crazy. Like, what happened to these people? Are they all in jail? Are they dead?" And he was like, "Oh no, like some of them work here." And I was like, "Excuse me? You mean you brought me to this place and these guys are working here?" And he's like, "No, no, no, but don't worry, like they won't hurt you. They were doing what they needed to do to feed their families. The thing that happens in the midst of this stability is that the groups that really want to take advantage of this situation, they will find people who are otherwise just good people that want to put food on the table for their families, and pay them like to put money on their pockets to do whatever they want them to do. And if that is making weapons, bombs, and IEDs, then that's what these people were doing. But by giving them a better option to come back to work and operate cement tumblers and processing plants and things like that, then that is work that they can be proud of. It still puts food on the table, but also they can be proud of what they're doing and be, a constructive member of society. And I remember thinking back to my time in Pittsburgh, how people would make judgments about people who were homeless and the gangs, basically young people that didn't have anything to do because the employment rate was so high. And I found myself having this moment where I was judging those people the same way people in my hometown used to judge people in my community. And it was a very humbling moment, but also it emphasized the work that I was doing, the importance of the work that I was doing there, and also created this desire for me to want to give this same type of skills or the same type of work that I was doing there back to my home communities. So that was one of the biggest lessons I think I learned during that time.
That's an incredible story. I don't think I've ever heard you talk about this. And it's no, it's mind-boggling because I think right now in America, we're starting to see that reindustrialization, right? Especially with the pandemic, we found ourselves in a position, and not just America, but the rest of the world, we found ourselves in a position where our supply chains crumbled because we had literally outsourced more than 90% of our manufacturing base outside of the country. And so during the pandemic, or when the pandemic happened, the decision for a lot of the maritime transportation, logistics, a lot of that sort of went away, or should I say, were paused because people weren't sure what was going on, and then all of a sudden there was this uptick in demand, and there was no semiconductor chips. Just, I mean, we're going to go into this. We're going to unpack a lot in this discussion, but it's just mind-boggling to me. And what year was this that you were in Baghdad working?
Yeah, this was 2008, 2009. So
Okay.
yeah, about 15 years ago.
Wow. So then from PwC, you moved over to, is that when you decided to go to business school, or did you transition to Google at that time?
No, that's exactly the time I went off to business school. So I came back. I went off to Harvard Business School for 2 years, and from that time in business school, I just really found some time to get reconnected to what it was I wanted to do in my career. I spent a brief stint at Google working in the finance operations team, and that was fascinating. My first time working on the West Coast in Silicon Valley for one of the biggest companies there, and so I think it was a great kind of place to be indoctrinated into the tech industry.
Yes.
But I was really still looking for my calling and working in an industry or a company where I could make a hard goods product, and at the time, there weren't really that many options. Apple, I think, was the biggest of the, I'll call them hardware companies. But most of the manufacturing of Apple's products were still outsourced to other countries, like Foxconn factories in Shenzhen and semiconductors coming from Taiwan. So most of the supply chain professionals there spent most of their time traveling to Asia, working with supplier partners there. And that while that was somewhat interesting to me, it was around that time that Tesla was coming into its heyday, and a friend of mine was at the company, and he was telling me about this company that was making these electric vehicles. He asked me, "Hey, have you ever heard of Tesla?" And I was like, "No, I've never heard of it." I was remember looking them up on YouTube, and I was like, "Oh man, this is crazy. These aren't golf carts; they're performance cars." And so it wasn't really until I had a chance to drive one and ride in one in person, when I was became just really hooked on the company, and that's when I reached out to see what opportunities were there for me to work on any of the teams there, and it turns out there was a really strong need for someone to help source the manufacturing equipment and automation equipment that was used to run the factory. As it turns out, there was a already pretty strong supply chain or procurement function, but most of the procurement leaders in the company were focused on sourcing the parts for the vehicle in what you would call the bill of materials. And those would be things like rear view mirrors, seats, carpets, trim, all those things have a number inside a bill of materials that someone is tracking and finding a supplier partner to make that part. But that wasn't what I was doing. When I was brought in, the real mandate for me was to find the equipment. And so none of my parts ever went into a vehicle. They all became part of the factory that was used to either make metal parts or plastic parts, painting the
Hmm.
parts, assembling the vehicle. So all of that is what we categorized into capital expenditures, and I became really the first CapEx procurement person at the company.
Wow. Okay. So let us backtrack a little bit. When you first drove Tesla, what model had been released at that time?
That was in 2012, I believe, and they had just released the Model S. So
Ah,
my friend was a former business school colleague, and I remember in that summer, he just gotten a job in the sales team. So he had a sales vehicle he was able to drive and showcase with customers. And he brought the car to my wife's birthday party. So we were like, "Hey, come out to the birthday party." He's like, "Oh, I'm going to bring the car by. I'll be able to, I can show you, and in case anyone else is interested, you guys can come and check it out. So when I tell you that the party stopped, like I think someone came to me before I even saw my friend. They were like, "Hey, there's a guy outside that has a Tesla." Everyone in the kitchen kind of cleared out, and they were all huddled around this car. I was like, "Oh, more people know about this than I thought." So we spent
Interesting.
the rest of that afternoon driving, joyriding up and down. This was Montague Expressway through Santa Clara where we lived, and everyone was just completely taken. And I was like, all right, this I see the potential in this. Super excited about what the company's building. What can I do? How can I apply my skill set to what this company is building? And I ended up joining Tesla in 2013, and I was there until about 2018, actually.
So during the time, that must have been cool to be able to, at least at that time, because it's not as though, not for, I guess, lack of trying, that a lot of auto manufacturers just could not seem to understand how to not only procure, but to build and then deliver a fully functional electric car. So that time was revolutionary, right? I mean, am I correct in making that assessment?
Yeah, you're totally correct in that assessment. And I'll tell you the thing that was different about what Tesla was doing at that time. There were there was a trend. So I think that there were other companies that saw an opportunity to build electric vehicles and saw the potential there. The the hard thing about
Mm.
making vehicles at this point in time is that there were very few, if any, industrialized suppliers that made the parts of the vehicle that you need in order to make this car. So let me unpack, like, what does that mean? When imagine trying to build a futuristic product and that no one has ever built before. And if you're going out and you're looking for a company that makes battery cells, and isn't a company out there that makes them at the scale or the volume that you need, then you have to improvise. And so what Tesla did is they took computer batteries, like literally laptop batteries, and they bought up as like the world supply of laptop batteries, bundled them together to put them into a battery pack, and attach them to these motors. But the motors of the vehicle were they also needed to be built from scratch because there wasn't a company out there that made electric motors for EVs because surprise, they don't even exist yet. And so there are a lot of these Gen 1 types of things that are problems that you need to overcome if you're building anything that's first of its kind. And so at Tesla at this time was really trying to reconceive how they could not just build the vehicle, but also industrialize a supply base of companies that have even a little bit of infrastructure that they could work with. Tesla could invest some money into these companies and what they call supplier industrialization and get these companies to make things at the production volume that they needed. So I can go through lots of examples of how this happened, but that was really the biggest problem that they were trying to solve at this time is figuring out first, where do we even get the ingredients for an electric vehicle if no one makes these yet? And if we can't find them, then how do we make them? And that's why my job became a really critical function because I was helping our internal teams build systems and manufacturing lines for things that didn't exist anywhere else in the world. And that is also a really challenging thing to do when it's the first of its kind.
It, I'm always fascinated with his politics aside. When you see someone who really thinks about the problem on a first principles basis and says, okay, let's deconstruct and let's rebuild. So the fact that he understood this problem and he was able to literally help pretty much create a whole new industry, but then also helping the other participants to also industrialize and bring on the capabilities to be able to actually support the mission.
Yeah.
I just think I think we need more, in my opinion, we need more leaders that are able to kind of get out of the status quo and question the core function and basis. And I feel like people who come from that cloth, from Tesla, I feel have that mindset. It's very similar to people who've worked for Amazon, and they have a different, similar mindset, but very different, that really comes from that founder. What are your thoughts on that, and how do you feel that has helped you in forming Diagon?
Great question. I'd say that Elon his brain works differently than most people's brain. And that first principles thinking is something that a lot of people talk about, but very few people know what that actually looks like in practice. And what that looked like at Tesla was this idea, first of all, with radical simplicity. So
Yes.
we had this saying that the best part of a vehicle is no part, where we would go through the bill of materials and say, you know what? Why do we have this wire harness? If it's to power this thing, do we need this fan? And if we need it, is this the way that we need to power it? Like, how can we reduce this? How can we simplify it? And how can we eliminate as many parts as possible from the vehicle? When you eliminate parts, you eliminate the need to have to make that product or have it be made. You eliminate the manufacturing process required to make it, which lowers your capital expenditures. You eliminate what do we call it, them failure points, like places where you could experience a mechanical failure, because the more things that need to work together in concert, the more times you're multiplying that small probability of failure together. And so anytime we were able to remove a part, remove a manufacturing process, remove a feature to make the product simpler without sacrificing the quality of the vehicle, that was something that made the vehicle cheaper, lighter, faster, and overall improved the customer experience with it. So that was kind of beaten into us, like beaten into me and many of the other people that have come out of that school of thinking when they're thinking about, what is the next thing that the world needs? Electric boats, or the next generation of rocket launch vehicles or satellites. People are constantly thinking about, like, what's the problem that they can be solving, and how will it eliminate a swath of other products that are no longer needed or rendered obsolete, so that you can advance the market with whatever product you're making.
Right.
Mhm.
Yeah, I think, especially when you watch his approach to how SpaceX, it's like, it took a whole NASA and they still couldn't figure out how to, in terms of the rockets and launching. And so anyways, but I just find it fascinating whenever I get to speak to someone who's actually worked closely with him. So let's before I get into the next section, which is about founding Diagon, your mission, any pivotal moments during your tenure at Tesla that significantly impacted your career, other than just the first principles thinking? Just if you can maybe share a little bit of a story. I think when we met in person a few weeks ago, you were telling a story of how Elon slept on the manufacturing floor, but I had to run because I was late for my flight, so I missed the whole story. You don't have
Let's
to share that
unpack it.
story, but maybe
No, no.
something similar to it, because I think that's I was like, oh my God, should I miss my flight to hear this, or should I?
None of the stories are worth missing your flight. I'll tell you that. But I will say there were, there was. It wasn't necessarily one specific moment in time, but I'll say that this unfolded over the process of maybe 'll say like 6 to 12 months. Um, the transition that I remember experiencing was in 2015 or so, would have been the year when Tesla was just launching Model X and evolving its philosophy to build Model 3. The two vehicles couldn't be more different from each other, not just in how they look and what they are. Model X, sorry, being a large SUV vehicle, and Model 3 being a small passenger car vehicle. Both electric vehicles, but very different philosophies in how the vehicles were designed and the manufacturing systems were designed. Um, I remember with the Model X, we have this section of the factory called Body in White. And this is the section of the factory where, if you've ever seen videos of Tesla's manufacturing process, there are all these robots, typically like hundreds of robots. Like we had, I think, over 500 robots on the Model X line, and they're all kind of putting the vehicle together. They hold it together and what they call framing. And then there are these little weld guns that go around the vehicle, and they do spot welds, they do riveting, they do all kinds of different manufacturing processes. There is and they start in different sections of the vehicle. So there are subsections, like there's one subsection for doors, and they have an inner part of the door and an outer part of the door that they marry together. And there is the outer part of the door folds over the inner part of the door, and in what they call a roller hemming process. They This part of the line is called closures, and on a standard vehicle, there are 6 closures. There are the doors, front, front left, front right, rear left, rear right. Then there's the hood, like the front lift
Right.
gate, and the
Yeah.
trunk. Those are 6. On the Model X production line, I remember budgeting our manufacturing spend for our closures section, and we had 6 stations, one for each of the doors: front left, front right, rear left, rear right, front and back. But when we were looking at the design of the vehicle and evaluating it, one of the things that came out of this process is that the rear doors were actually 2 doors. So for anyone that's familiar with a Model X, you've seen that there are these falcon wing doors that lift up, and there are
Yes.
2 doors that are actually hinged together. And because the upper and the lower are different closures, we had to add 2 additional stations into the manufacturing line in a space that was already space constrained, in a program that was already over budget and over its timeline. This was like an immensely painful process that was not intentional. Like, no one intentionally said we're going to create more complexity in this vehicle. We just saw that there was a cool design that we wanted to build, and it turns out that that design was very hard to manufacture. So we ended up doing it. We finished the line. It was massively like over budget, but because of that. But what it forced was a rethinking of how to simplify the vehicle. So I remember in the months leading, or the years leading up to Model X, I saw very little of Elon's presence on the manufacturing engineering team and manufacturing engineering processes. He spent most of his time designing the vehicle and making it the coolest spaceship of a vehicle that you can imagine. That ratio of time was drastically pivoted between Model X and Model 3, where yes, there was a lot of time spent on designing the vehicle and simplifying it, but much more time thinking about what's the manufacturing process that we're going to use and how do we simplify it. And so in that process, I remember going in these review sessions where we would look at the vehicle and we would say, hey, Elon, we've got, I don't know, $100 million dedicated to joining equipment for the manufacturing line. And he would say, what the expletive are you guys thinking? Like, why are there so many different types of joining techniques? and we would go through them and we would say, well, we have spot welding, we have MIG welding, we have self-piercing rivets, we have stud weld, we have all of these other like gluing and dispensing applications, like 50 different ways of joining the vehicle together. He's like, it's one damn vehicle. Why are there so many joining techniques? And it was because there were all of these different pieces of the vehicle that needed to be put
Mm.
together. And we were mixing material types in a lot of places. So Model X and Model S, most people may not know this, but they're mostly aluminum vehicles. It's a very lightweight metal. It's easy to kind of manipulate, and you can simplify because there are certain types of welding techniques that you can use when you have one consistent metal. But when you're mixing materials and you have titanium and steel and other things that were introduced in Model 3, that means that you need to accommodate for those different joining techniques in the manufacturing process. So one of the things that we did was we simplified the mix of materials that we had in the vehicle, and that took out half of the manufacturing processes so we didn't need those joining techniques processes anymore. And then we also look for ways to commonize. So instead of using two manufacturing techniques where we could use one, MIG welding or another one, we were able to simplify that. And that's how we were able to get the complexity of the manufacturing process down by simplifying the metals and materials in the vehicle. And so that really kind of goes back to that first principles thinking that we talked about earlier in the conversation. The more you can simplify the product that you're building, the more you can simplify the manufacturing process, and it has positive ripple effects throughout the rest of the system that you're putting together.
And so then that's why there was this timeline, this deadline, and then he's like, I'm staying here until you guys figure this out.
Yes, that's because we had lots of other problems. I think we did a lot of experimentation as well with the Model 3 line. We were looking to make that the fastest, densest, and simplest manufacturing line that's ever been built. And so the goal there was to really see where we could push the envelope with accelerating or making the manufacturing processes faster, but also looking for ways to make the processes simpler so that we were able to use fewer things in the process.
Wow, that's amazing. I just want to pause for a second because we have a couple of live people here listening in. So please just make sure that all of you have your audio on mute. And if you have any questions, please feel free to drop them in the chat. And if you are on a live stream and you want to contribute your comments and or your questions, please go ahead and use the Zoom link wherever we have posted this on Luma and also on LinkedIn as well, Katalyst Point. So let's dive into Diagon because the reason I really wanted you to articulate your experience from PwC to Google, other companies, and then to Tesla is really what inspired you to start Diagon. So you left Tesla and then what?
Yeah, so I left Tesla in 2018, but before I left Tesla, one of the things that I think was worth highlighting is that um, earlier in our conversation, I was highlighting this idea that we at Tesla already had a procurement team that was mostly dedicated to sourcing parts for the vehicle. And so when I joined Tesla, I was the only CapEx procurement person in the company. And the scope of things was growing like larger and larger over time. And so what that meant is that I had to start building up a team. So I ended up building a team of 30 plus people. We were managing about, $700 to $800 million per year in capital equipment spend and budget. So, billions of dollars in responsibility. And I think the thing that I was most struck by was the lack of sophistication in the tools that are used to build multi-billion dollar state-of-the-art factories. We were still using largely email, wiki pages. If anyone's familiar with Confluence, that was like our number one, tool for kind of collaborating and getting thoughts together. And I started to grow jealous of my friends in the direct materials, like bill of materials space, because across the board, when it comes to procurement, in the industry, 80% or more of the buyers in the industry are focused on sourcing the parts, machine parts, injection molded parts, electrical like PCBAs and other things. They come from certain categories and specific suppliers. And most of the software tools also are built to serve that audience. On the capital equipment or CapEx side, we represent less than 5% of the industry. And I think that that's a generous estimate. And so most of the needs of that segment have been largely ignored. And what I mean by this is, if I were to give a poll, like how many people could name 3 to 5 companies in the world that make battery cells that can be used in electric vehicles, most people could do that. They would tell you, oh, I've heard Samsung does this, LG, Panasonic, CATL. They're kind of household names. I would say closer to household names than others. But if I were to ask how many people know companies that make equipment for building battery cells, winding equipment, coating lines, battery cell assembly, and mixing, most people couldn't even name one company that make those types of things. So the types of suppliers were very different. The volume and complexity of the products that I was used to sourcing were very different. And the timeline, like my average timeline for a project was 6 to 18 months. So if you're setting up a new manufacturing line for, let's say, Model 3, and you've got 18 months until you need start of production, you're probably already behind the 8 ball because most of that equipment has lead times that far outstrip your program timeline. And so that was the challenge that we faced. So given that there was a very unique set of challenges, a unique set of suppliers, and a unique set of requirements, most of the tools that were pitched to me when I was in that role never really worked for my category of spend that I was managing. And that was the first part. Is like there is a big problem, there is a need for that type of product. The second question, and I'm kind of breaking this down like a VC would break it down now.
Yeah, no, which is great. we actually want this because I think, a lot of times, please, yeah, finish because I'm all about the details. As long as you have time.
I've got the time. So these are the details. The other thing is, the question that I often get is this a problem that just Tesla was facing because they were building so much on their own? Or is this something that other companies face as well? And if you look across the board at companies that are manufacturing or making anything within their 4 walls, there's somebody in that organization that's charged with the responsibility of identifying suppliers, negotiating quotes, and making sure that projects get delivered on time and on budget. Most often, what I discovered is that those people end up being someone that's outside of the procurement organization, even if the company has a procurement organization, which was kind of surprising to me. But most often there are engineers, manufacturing engineers that get charged with that responsibility, or executives like a CFO or some other kind of budget owner within the company that's trying to think like, how do I get my team the tools that they need to make the products that we want to sell to the public. And I think that that's all fine and good, except for the fact that most people aren't formally trained or have never formally been trained in or experienced in that mode of procurement. And so what I wanted to do was to not only serve companies like Tesla that had supply chain or let's call them CapEx procurement professionals, but to also build this tool so that it could be usable by technical buyers and executive buyers and other profiles of people that have full-fledged day jobs and they're doing this in their part-time as a separate role. And so those are the things that really led me to understand that this was a problem that was much broader than just what Tesla was experiencing. And so when I also thought about the market for this equipment, the market for manufacturing equipment is a multi-$100 billion a year market just in the US. And even outside of the context of reshoring, nearshoring, and all of the other tailwinds that are pushing companies to make more domestically. And so there's also a huge market here for manufacturing equipment, and those things together, I'd say that they all pointed toward the need for a product that was a key enabler for for the people that would be using it. And the goal really, I'd say that a very micro way of looking at what we do is that we're building this procurement tool, but really what we're doing at a macro level is we're helping companies build factories, and we're helping them do that on time and on budget with the teams that they have today, and giving them capabilities that they would never otherwise have. So when I think you look at what we're doing at Diagon in that expanded view, I think that there's never been a better time to launch something like what we're doing. So feel
Yeah,
free to ask me questions.
your timing to launch, first of all, is impeccable. And I believe it's because of your true understanding about how all this works and how it's all interconnected. And quickly, I'm a big brand person. So when I hear company names, I'm always curious how the company name came about. So before we get into the more of the technical stuff, can you share your vision when you thought about Diagon, why the name and what that mission was?
Yeah, great question. So initially, I conceived of Diagon as a marketplace for manufacturing equipment, and I was thinking of names that fit that kind of profile, names like Automation Mart or something in that vein. And I've got a family, so my kids and my wife are pretty. They like to know what I'm working on, and they hated every single name that I threw out there. They were like, "These names suck, Dad. You need to figure out like a better name for your company." So one of our family traditions is that we watch the Harry Potter movies every Christmas from episode 1 all the way through 8/9, and the coolest marketplace is Diagon Alley, where the place where you can find anything. So that's where the wizards go to get their magical supplies. And so this was kind of a nod to Harry Potter and my inner geek.
And this is my inner brand strategy person, geek. I'm always curious, and that is amazing because it really fits in with what you guys are doing. Okay, so how does Diagon's capital equipment procurement platform differentiate itself from others in the market? For example, I think when we hear procurement equipment, we think, the big guys such as SAP and whatnot. Like what makes your product, the solution that you're providing different from them and any of the other players currently in the market?
Yeah, that's a great question. So when you talk about companies like SAP and Oracle, and others that have developed, let's call them ERP systems, and with procurement modules that do the procure to pay process, they're very different than what we're building, because those systems are more of a system of record where the company CFO is typically the end customer or the primary customer for an ERP system. And the systems are mostly used to document purchase requisitions, purchase orders, the payment process, and reporting out on the numbers. What I recognized, or what I realized in my time at Tesla, was that I was a user of our ERP system. We had an internal one. We had SAP at first, and we used an internal one called Warp Drive. But by the time I was starting a purchase order requisition in Warp Drive, I had already done, 3 to 6 months worth of work to get the quotes that I needed, in order to start that requisition. And what that 3 to 6 months of work looked like before I ever used SAP was identifying my specifications, putting together requests for quote, requests for proposal, sourcing suppliers, which companies out there make the products that I want to buy, gathering quotes, negotiating those quotes and making sure that we had the best price and lead time for what we were going to buy. And once I was down selected to the one supplier that had the quote that I wanted to write a purchase order against, that was the point at which I started using our ERP system and documenting that into a purchase order. So that was the difference between the work that's done beforehand, where there's a system of work that needs to be there, versus a system of record. And additionally, after I wrote that purchase order in SAP, there was a ton of work to be done afterward. And so what that work looks like afterward is, now that I've written a purchase order to that supplier, the one supplier that I've selected, I have to do a final design review with that supplier and make a milestone payment to them, to say like, hey, here's 10% down payment for what you guys are about to build for us. We have factory acceptance testing where we go through a checklist of items to make sure that that equipment is working at the supplier's factory before we ship it. There's shipping, installation, and site acceptance testing that needs to be done. And all of those things are still done outside of an SAP system. So really the ERP systems were kind of like a comma or a punctuation in this long continuum of responsibilities from planning all the way through to start of production. And so what I was looking to build is a system of work where engineers and procurement leaders could spend their time finding the right suppliers, down selecting and managing their projects, and for sure connecting into the ERP so that you can manage your payments and make sure that projects are on track. But that's really the magic in what we're building, is everything that happens outside of the normal ERP process.
Wow, that's incredible. And so you go out to, you say, okay, this is my idea. You were a solo founder at the time.
Initially, yeah.
Initially, and then you say, I'm going to go out. And what made you want to go out to raise VC? Or did your co-founder Shri come in before going to raise? Like, walk us through.
Yeah.
Now you have this amazing idea, you're solutions provider, then what?
Yes, great question. So the first thing I realized was I wanted to build this software platform or marketplace, but I've never really so much as built a website, let alone a software product. So I know what I want out of the product, and I know this domain as a user, as a supply chain or procurement leader, but I needed the person that could help with the technical aspects of building the platform. And so Shri and I teamed up pretty early on, and we have two other co-founders, Greg Smythe. So Greg is a former Tesla colleague. We've both worked in procurement before, and we were building our go-to-market strategy as such. And Clara, so Clara is a product designer. And so between the four of us, we were able to build really scrappy first-generation product and to build these prototypes that that worked, but that had no possibility of really being able to scale yet. So our initial go-to-market strategy was that we were a fractional CapEx procurement team. So think of us as the team that I had at Tesla. We were very privileged to have a team of 30 people. The company Tesla invested, $4.5 million per year conservatively to employ my team. Most companies don't have a team like that can go out and execute, that has experience, domain experience in this space. But we could be that team for these other companies. And so what we did is we would essentially provide services on a fractional basis to companies that were building new manufacturing lines and that needed that procurement capacity. And as we were doing that and rendering those services, we started building Diagon to be the internal tool that we ourselves used to document the suppliers, building our supplier network, building up what do we call them, like quote evaluation and comparison tools, and all the other things that help make our jobs easier. And we did this with the mindset that if it makes our jobs easier, then at some point we can actually sell this as a standalone product that our customers can use, that enables them to do a lot more on their own than what they could currently do.
Kind of reminds me of Jason Fried, how he started Basecamp was because, 30, is it 37 signals, 39 signals, but, he pretty much it was a product that they were using internally. And then he kind of flipped that product and actually started selling it because again, that was there, that need to solve the problem was there. So then you guys have your minimum viable product. You have a small nascent group of customers who are helping you validate these products and validate the solution that you bring into market.
Mhm.
And then what was the constraint that led you to say, okay, we need to go out and get VC money in order to scale the
Yeah,
company?
great question. Great question. So, yeah, the way that we were thinking about this is that we first wanted to prove that there was a willingness to pay for the problem that we were solving. And I think that this is something that lots of founders miss out on because it's easy to get the wrong signal from a would-be customer.
Right.
So I'll separate what the framework that I use to separate signal from noise is that when you're building something for the first time, your instinct is to go out to the people that you know, build something and say, would you use this? Or what do you think of this cool thing that I built? And these people, if they're close to you, or even if they know you from prior work experience, they'll tell you like, oh, this is really cool. I like what you're building. I would totally use this one day. But when you ask the key question, would you pay for this, or will you pay for this now? And how much would you pay for it? That's when you recognize whether you actually have a monetizable product or not. And we fell into that trap at first. I think we were quick to recognize when we were in it that we started building a product that people weren't necessarily ready to pay for or ready to buy. Where we started to try to get that signal was when we flipped the question back over to those customers and asked them, hey, here's a problem that you're trying to solve today. Will you pay us to solve this problem for you? And how much will you pay us? That's when we started getting real positive signals about how much they were willing to pay, how frequently we found customers that were willing to have this product, this problem solved for them. And the way that this manifested wasn't that people were asking for CapEx procurement software. Most of our early customers were like, hey, this is really cool that you're building software, but I need you to just solve the problem for me. Like, I actually want you to go out and help me find 3 qualified bids that you've already negotiated, where there's a good price and a lead time that meets my needs. And I'll select from there the one that I'm going to write a purchase order against. If you solve that for me, I'll pay you money. And sure, I'll test your software out and be a beta user and all of that. But that was really more of an afterthought for them. So for us, that first problem that we were trying to solve was to find the willingness to pay, who is the paying customer, and what is it that they're paying for, and like to see how big of a market there is for that problem to be monetized. So I think once we were able to get to that point, then we started to see that there were positive signals, and that our real only constraint at that point was building out more of the software tool that we needed, and needing to hire developers and to start putting people against this problem that to start building it. And that's really what compelled us to start seeking venture funding, where we first got our first pre-seed funding that we did, helped us get to market and get some validation around what we were building. And the second round that we did was a seed round. And that was really built on, hey, now we have some bigger customers that have bigger problems that we need to solve. And we need enough runway to grow our customer base and to build out our product to be a substantial product. So that's really the part that led up to getting the VC funding and then building on it.
Just so if I understand you correctly, so minimum viable product, you had your customers even before your pre-seed round who were willing to pay.
Can I maybe make a quick
Yes.
modification to what you're about to say? Finding the customer before the minimum viable product was actually really the key there. Because I think most companies, a lot of startups think that they have their minimum viable product, but until someone's willing to pay for it, it's still not really an MVP. So finding that paying customer first and then building the product that automates the problem solving process was the light switch that I didn't even know I needed. But that's the way I
Mm.
describe it.
It's so funny because we had a professor when I was at Babson, and Bob Caspi, and he had this marketing class. And instead of giving us exams, so what our project was to go out to any business. He didn't care what business. And he gave us a set of questions. And he goes, this is how you start a company. You go out, find a problem, and then you can come back and say, and maybe build or maybe figure out what that solution is and go back to the customer and find out how much they're willing to pay for this solution now that you've solved that problem, and then build that MVP.
Yes.
We all
Yes.
thought he was crazy, but he was also one of the favorite professors at Babson. And your journey and what you're saying validates that concept. So then
Right.
you go out to VCs, and then then what?
Then you take a beating.
Lots of meetings.
You take a beating. There are lots of meetings, and the general disposition for most VC investors is that this isn't going to work. Maybe there's something you missed about the problem. Maybe there's something you misinterpreted about the solution for that problem. Maybe. And if they smell that there's blood in the water or think that there's something off with the pattern recognition, then most often you're going to get a no. And that's fine. That's the way the VC industry is supposed to work. It's supposed to be the riskiest money, but it's also supposed to be to put the onus on the founder to lay out the case for the investors. And I'll tell you that the way this conversation went with most of the investors was, look, we've seen really cool marketplaces and procurement platforms that have been built for things that are very different from what you're doing. So in the parts world, you have lower complexity parts that are relatively easy to define. The buyer's buying them in pretty big quantities, hundreds, thousands, or even millions at a time. And the suppliers are a different kind of supplier than what you're used to working with. But also the transactions are relatively frequent. We look at what you're building. You've got these high complexity specifications for the equipment. You have low transaction volume, where this company might be building one of these lines every year or every 2 years. And the duration of these projects is really long. None of this matches any of the patterns that we've seen for successful companies. Why the hell would you want to build a company in a space that has dynamics that are this ugly? And it took a few times taking that beating before I realized, like, I have to lay out a case for why it's good that we're different, and why this is a problem worth solving, and that the things that they're worried about aren't as worrisome as they believe they're going to be. So what that means is, the way that we solve this problem, or at least the way I solve this problem with the investors, is that the high complexity of specifications means that there's an opportunity for standardization. So what generally happens if you're sourcing autonomous guided vehicles and you go out to 5 different companies, they have 5 different intake forms. They're all asking for generally the same information, but because no one's gone to the effort of standardizing that intake process, it just hasn't been done before. And so that's the first problem that we're solving. The low volumes, I think we can make up for in the transaction size. So if you're buying 1 million batteries, you're going to spend about the same amount of money as if you're building one battery manufacturing line that can make 1 million batteries. But the transaction size is, in the tens of millions of dollars, not, $3.50 for a battery cell. So that was the second thing. And what we lack in the volume, we also make up for in the duration of the project. So I described, in my SAP comparison example, the 3 to 6 months of work that I did before we wrote the purchase order, and the 6 to 12 months after we write the purchase order, we have that customer for the entire duration of their CapEx journey, from the time they start planning and putting their specs together until the time when they're finished building that manufacturing line. And so there's a stickiness that's here with our product that you don't have with other categories. And it took me, I don't know, maybe 12 months to figure out how to tell that story in a way that was digestible, understandable, and compelling and interesting enough for VCs to want to invest in it. But once you get one or two investors on board, especially if they have a good name and reputation behind them, then people start to see the magic in what you're building. And I think that that's really the point that we're at now. So that's a quick overview of my fundraising journey. It took us about 130 to 150 calls to get to the 6 to 8 investors that eventually put money in the company. But I think that if it weren't for going through that journey and getting lots of rejections up front, we wouldn't have as much clarity of vision and clarity of story without going through that refining process.
Yeah, no, that's pretty incredible. Because it's I think it's Hamilton Hammer who wrote the book Seven Powers, and in that he actually talks about stickiness. A lot of times recurring revenue is great, but you really want a sticky customer, right? A long time procurement period. So now that you've raised this money, you guys are refining the product, I'm assuming. And who is your ideal customer?
Great question. So yeah, we're in the process of building building out more of our product. Our ideal customers are any company that's manufacturing within their 4 walls that needs to invest in capital equipment. They're going to have to do this process regardless of whether they use a platform like Diagon. The question is, can we make it easier for these customers? So most of them, most of our current customers, they tend to be tech-enabled products. Most of them are in the automotive, aerospace, semiconductor, or renewable energy markets. So they're building products that are in those industries. And what we're doing is helping these companies get the equipment they need to make their products. So any companies in those industries, I would say, are best suited for what we can do today. And we've got a pathway to working in other industries like biotech and other types of equipment that are a little more specialized and slightly outside of our wheelhouse for what we do today, but they're suffering from the same problems. So that's the way we're thinking about our future roadmap.
Wonderful. And so, taking your experience from Tesla, taking your experience building Diagon and solving the customer's pain point, what is your vision for the future of factories? And especially when we look at the thing called a gigafactory, where and I'm going to leave you to explain this because that's not my wheelhouse. So talk about gigafactories. Are they the factories of the future? And if not, what needs to happen in order to start putting together the factories of the future here on American soil?
Yeah, great question. So, I think when most people refer to gigafactories, they're referring to battery factories or solar factories and things that can make, these types of products at really impressive scale. And I would say that while those are examples of factories of the future, they're not precisely the way I would think about how I describe, this core market and this core customer. When I think of factories of the future, it really comes down to three elements, or there are 3 elements that I look for that tell me, how future facing this company is. The first thing is the product. So is the product something that is forward facing or tech enabled, or a key enabler for other technologies? And so that first thing is really the first marker. Some examples that I see of this are semiconductor factories that are being built to build new chips to empower AI. I've seen companies that are making really cool applications for battery powered vehicles, boats, cars, drones, all types of things. Any of those products, I think, if the product is tech enabled or an enabler for key technology, that's the first criteria that I have. The second criteria that I have for a factory of the future is what type of equipment or manufacturing technologies are they using to make their products? So in semiconductor manufacturing, there's a ton of etching and deposition and other types of manufacturing processes that are highly automated and very future facing. The same for other industries, like in in automotive, there's heavy use of robotics. In the aerospace or space tech industry, 3D printing, and even the test chambers that are used to test the firing of ion-based thrusters and rocket engines. Those are tools. I would say they're the tools of the future. So that's one of the second criteria. The first is the product. The second is the manufacturing tools that they're using. The third thing I would say is what are the software tools that the companies are using? And this can be everything from their procurement tools, like teams, the future facing teams that I see are using products like Diagon for sourcing their manufacturing equipment as a way to help their teams scale and to do things at an outsized scale. There are lots of other companies out there that do, bill of materials sourcing and software sourcing. So those types of tools, I would say, are really the third marker. And whether they're employing those software tools on their manufacturing lines as well for things like quality inspections, manufacturing execution systems. There are so many places where software can be applied, but that software, to get the best use out of the software, the companies that I've seen do this best also have enabling tools like sensors, cameras, and other things that help them understand their manufacturing process at a level that old school factories struggle with. So these are not something that I've found anywhere else. These are, I would call them Will's criteria for the factories of the future, are the products, the manufacturing processes and tools, and the software tools that the companies are using.
I'm curious to know what your thoughts are on human connection, like the people, the labor in those factories of the future, and how, the people can actually work with the manufacturing tools, the software tools. Like, how does that work in your world?
Yeah, great question. So, this is what I would actually consider to be the biggest constraint on our aspirations to build factories of the future. The problem is that there is a disenfranchisement in the labor force that I haven't seen before. And I'm not talking about like the white collar levels of companies. Engineering teams want to build really cool things. Product teams want to build really cool products. But at the actual manufacturing level, where you have production associates, production managers, operators, CNC operators, and managers of the equipment, we still have to overcome a lot of the battle scars of the past. So I started this conversation talking about my upbringing in Pittsburgh, the deindustrialization and where that put the people that I grew up knowing in my family that worked in factories, and people stopped seeing it as a pathway to economic mobility and economic stability. And so I think that that's really where things begin, is just changing the mindset of the type of work that needs to be done, and the people, like the mindset of the people that do the work. The other thing is that the companies, the managers of these companies, need to invest in the people that they're employing. And so um, the thought here is that if people feel that they take a job in manufacturing only to be laid off a few months later, then that doesn't instill confidence in the people that are doing the jobs. So that's the second thing. And the third part of this, there's been a lot of lip service to it with very little action actually put behind it, is upskilling of the labor. So when people come into these jobs doing with the so-called blue collar work of being a production associate, CNC operators, and things like that, with these tools of the future, there are going to be new skill sets that we haven't really tapped into yet. But training people and giving them an understanding of what they need to know in order to be a best-in-class 3D printer or manufacturer, that's going to be what sets people apart. And I think that's also going to be the thing that helps lead to more promise of upward mobility in this sector.
Yeah, I think the potential is huge, especially with upskilling and reskilling. The idea that there is, economic chasm between people in this future that we're walking into, especially with the advancement of AI and some of these IoT type of tools that can galvanize, factories of the future. I just feel that, we as a society, as a people, have the potential that everyone, from an economic standpoint, can actually contribute to society. And it is really about shifting the skills that were used before to what is being used now. And so when you think about maybe one or two companies or three companies that are doing the right things, your Will's criteria of future factories, what does that, who is doing that out there? Not just product manufacturing software, but also people.
Yeah, great questions. I'll say that they take a big beating because because of sorry, I'll start this over. I know that Tesla will take a lot of beating over the years, but I will say that Tesla is really the first company that I was able to witness firsthand doing that work of being one of those factories of the future. And of course, SpaceX, I think also falls into that category. I think companies like, companies like Arc Boats that are building these electric boats for naval applications, Saronic, others in the naval space. There are others in the in like automotive and solar that I think are doing the hard work. And these companies, I think, are the end users. They're building these factories. I'll also say that there are enablers on the equipment side. So companies that are building, the test chambers, 3D printers, those companies as well. They're going to be the biggest enablers of this next generation of companies. And I'll also give a nod to companies that are not necessarily the newest kids on the block, but they are really thinking about how to incorporate new values and new life into their companies. So companies like Intel are investing billions of dollars, like tens of billions of dollars, into new chip fabrication and manufacturing plants, and they're very much thinking about what does the next generation of product look like. Building chips for the AI revolution. What does the next generation of equipment look like? Building the chip fabricating plants that have the newest technology and are able to make the newest products. And then also, how are they upskilling their labor and, getting the labor force to be ready for what's coming at them. So, so I think that companies like them also owe a big shout out because they're doing the hard work and not necessarily getting the recognition because they're not these upstart companies that are getting $1 billion in VC funding, but instead they're getting tens of billions of dollars from the U.S. government to build what they're doing. So in some ways, I think they're flying over the radar.
Yeah, and And I think rightly so. So until that actually translates to profitability, right? Then maybe that's when that recognition will come into play. But that's years after the investment has already been made. So in addition to startups, in addition to the big corporates such as Intel, a lot of our audience are actual middle market, small, medium-sized businesses that have manufacturing plants. They employ 50 to 100 people or more, and revenue generating profitability, but they want to figure out a way to transform their manufacturing plants. Any advice for those folks out there?
Yeah, the advice would be to think really deeply about what your goals are as an individual company. There is no shortage of companies out there, software solutions and otherwise, that will want to sell services and products and other things into these, small, medium-sized businesses. But we have this philosophy at Diagon that we never make our companies buy equipment that they don't need. And so, and it takes a lot of restraint to do that because you can vertically integrate into just about anything. But the question is, should you? So the things that we try to ask our customers are, what are your aspirations for the products that you're building? Do you have enough manufacturing capacity today? Are you making the types of products that are going to, lead your company into the future and what your audience, your customers are going to want in, 5 to 10 years? And when we start with those questions, I think that helps us really hone in on what are their really acute needs and where can we help them get the tools they need to make those products.
Wow. Great questions. And also, the ability to be able to scale your business up or down depending on the type of customer, I think is pretty incredible. Let me see if I have any other questions. We do have time, a little bit of time for audience Q&A. I didn't know if there was anyone else in the room except maybe you and I.
No, there were a few, but I think they dropped.
Yeah.
But I'd be happy to also just even have follow-ups and to continue the dialogue on LinkedIn or wherever else. So yeah, let's keep the conversation going even offline.
Yes, I would appreciate it. Thank you so much, Will. This was fantastic. Appreciate the time.
Thank you, Belinda. I appreciate the spotlight and let's keep in touch.
Absolutely. Thank you. Thanks,
All right.
Will.
Thank
Bye.
you. Bye-bye.
Bye.